Hello. During session 10, we're going to be exploring multiplying and dividing a fraction by an integer. We really are wanting to start with a focus on understanding and using the correct language to explain the procedure of what's happening. You'll notice that every time we introduce something with the model maths, it'll be accompanied by a bar model, and it will also be accompanied by the sentence structure that we're wanting to use to support that understanding. If we look first at multiplying by 3, what we're wanting to do is we're wanting it to become something that they can visualize in their head rather than being an abstract rule that they're just applying without understanding the why behind it. In this example, we've got a quarter times by 3. What we want them to appreciate is that it's just like multiplying a whole number or an integer by 3. By multiplying by 3, you are having 3 lots of that amount. Okay, it's getting 3 times bigger. So we're showing here that we've got 1 quarter, and that by timesing it by 3, we will have 3 lots of those quarters, or a quarter 3 times. This means if we have a quarter plus another quarter plus another quarter, they should be able to appreciate from the fact that we've just done a session on adding fractions that this will be equal to 3 quarters. We're trying to avoid that common misconception of them multiplying the numerator and denominator by 3. Because this is what a lot of pupils were doing when it was the equivalent fractions. They were saying that a quarter is equivalent to 3/12, but then they were also saying that you have multiplied a quarter by 3 to get 3/12, so it's contradictory. So really we wanted them to have a deep understanding that we're only going to be multiplying by the numerator to actually make this quarter 3 times bigger. If we then move on to divide, obviously it has the inverse or the opposite effect. So timesing by 3 will make something 3 times bigger. Dividing by 3 will make something 3 times smaller. So if we take a quarter, we divide it by 3, then we are going to be splitting that quarter into 3 equal parts. So we've basically got a visual there of 3 equal parts. But that means that these parts now are different sizes. So this size piece is different to this size piece. So whatever we've done to one part, to 1 quarter, we'd have to do it to all of them to see how many equal parts there are in the whole. So if we've split this 1 quarter into 3 equal parts, that means that every quarter is split into 3 equal parts. And the fraction now is going to be 1/12. There are a couple of questions after they've had a go on the we do and the your turn, where they're just getting into the procedural practice. There's a question at the bottom that says, what is the overall effect of multiplying a fraction by 3 or another integer, or dividing by 3? What does that do to the numerator or the denominator? So ultimately, what we want them to appreciate is that when you're multiplying a fraction by an integer, that we're going to be making the numerator larger. But if we're dividing a fraction by an integer, the denominator will get larger because the overall fraction has got smaller. So it's going to be really hard for them to see that when a number increases, if that number increases in the denominator, actually it's making the fraction smaller. So there's a lot of real deep comprehension to be done, and their language will help with that. Once you've got that understanding, we can move on to the bit more rule-based, because there's no way they're going to be able to see, for example, here that 2/9 times 4, they won't be able to visualize that as well. You can draw a bar model, you could sketch one out for them, but essentially what you're saying is we're using that sentence stem. We've got 2/9 4 times. So we've got 2/9 and another 2/9 and another 2/9 and another 2/9. And we know when we're adding fractions, the denominator will stay the same because we're collecting ninths. And how many ninths do we have? We have 2, add 2, add 2, add 2. That's 4 lots of 2, which will give me 8. So that 4 lots of 2, 2 times 4, we get that 8 on the top. What I've shown here is that understanding of why linked with the sentence stem. The rule that as adults you probably just go, oh, we know we multiply the numerator. That's what we want them to remember, but we would like them to have that deeper understanding as well. 3/9 a little bit harder. We're dividing by 4. We know the denominator is going to be affected if we divide by 4. So that 9 is going to be multiplied by 4 to get 36. 36 are 4 times smaller than 9ths. I'm not sure if you want to draw a bar model for that. It might take a while. You could use go back to some more simple numbers, maybe do a half divided by if they still aren't quite understanding it, and showing them why that works, drawing out a bar model, a half, and we want to make that 4 times smaller, and therefore we would have 8s, and looking at the fact that it's made that denominator, just that number 4 times bigger, but the overall fraction is 4 times smaller, and our numerator will stay the same. At this point, you'll notice the numbers I've used, we can actually cancel that fraction down to an equivalent fraction. And that obviously is the same as a third, and that's why. Now, this is only for the pupils that need that stretch and challenge, the ones that have really deeply understood it, and we're moving on to that next step. So not all pupils will answer this question about what's happening with the answer to question C. But essentially, if you've got a numerator that is a multiple of what you're dividing by, ultimately that's going to become 1/12, because if you've got 5/12 and you're dividing by 5, you're splitting those 5/12 into 5 equal groups, and in each group there'll be 1/12. So they can visualize it or think about it that way. But if they go through it the longer way, so the way that we've set it up for them to think about it, where the denominator will be 5 times bigger, so 12 times 5 is 60, and then the numerator stays the same. We can now cancel that down because they're both in the 5 times table. So divide by 5 is 1, divide by 5 is 12. So if they see it like this, absolutely great. We've set it up for them to be able to answer it. If they can move on to that deeper understanding of 5/12 and splitting that into 5 groups and think about it that way, that's that extra stretch and challenge. But it's not for us to go, the whole group need to do that, or every pupil.